Imagine a massive market crash is happening. You need to withdraw your funds from a decentralized lending protocol immediately to avoid liquidation. But when you go to their website, the page won't load. The servers are overwhelmed, the domain has been seized, or the front-end developers accidentally pushed a bug that broke the withdraw button. For 99% of retail investors, panic sets in. They are locked out of their money. But in Web3, the website is an illusion. The website does not hold your funds, and it does not execute your trades. It is simply a convenient graphical interface built on top of an unstoppable backend. If you know how to bypass the front-end website and talk to the smart contract directly, you are truly sovereign. This guide covers how to read and write directly to the blockchain in 2026 without knowing a single line of Solidity or TypeScript. We will cover the mechanics of block explorers, the proxy contract maze, and how to execute emergency withdrawals when the UI completely vanishes. The illusion of the DApp, decentralized application. When you use a platform like Uniswap or Aave, you are interacting with two completely separate systems. The first is the front end, the HTML, CSS, and JavaScript, hosted on a centralized server like AWS or Vercel. This is what you see on your screen. The second is the backend, the immutable smart contract deployed on the Ethereum, Base, or Arbitrum blockchain. When you click Swap on the website, the front end simply formats a message and asks your MetaMask wallet to sign it. Once signed, the transaction goes to the blockchain, entirely bypassing the website. If the front-end website goes offline, the smart contract on the blockchain does not care. It is still sitting there, fully functional, waiting for mathematical instructions. To send those instructions, you just need a different interface. In 2026, your primary emergency interface is a block explorer. The ultimate tool, Etherscan, and L2 explorers, block explorers like Etherscan for Ethereum, BaseScan for Base, or Arbiscan for Arbitrum, are not just databases for tracking transactions. They are fully functional, zero-code smart contract interfaces. To interact with a contract, you first need its exact on-chain address. You can usually find this in the protocol's official documentation or your own past transaction history. Once you paste that address into the Block Explorer, you will navigate to the Contract tab. Here, you will see a green checkmark if the contract is verified. Verification is critical. It means the developer has publicly uploaded the original, human-readable code, and the Block Explorer has successfully matched it to the raw hexadecimal bytecode living on the blockchain. More importantly, verification gives the Explorer the contract's ABI, Application Binary Interface. The ABI is the translator. It takes the unreadable machine code and generates clean, clickable buttons for every single function the contract can perform. Without the ABI, you would have to write raw hexadecimal transaction data by hand. With the ABI, interacting with the blockchain is as easy as filling out a web form. Read versus write, the two modes of interaction. Once on the Verified Contract tab, you will see two primary subtabs, Read Contract and Write Contract. You must understand the distinction. Read Contract, no gas, no wallet required. Reading data from a blockchain is entirely free. You are simply querying the current state of the ledger. You do not need to connect your MetaMask. Here, you can query functions like BalanceOF to see how many tokens a specific address holds, or total supply to see the maximum amount of tokens in existence. If you want to know exactly how much of a token you are legally allowed to claim from a vesting contract, you query the claimable balance function. You get absolute mathematical truth, unfiltered by a buggy front end. Write Contract, gas and wallet required. Writing to a contract means you are changing the state of the blockchain. You are moving money, updating permissions, or trading assets. Because this requires computational effort from the network validators, you must pay a gas fee. To use this tab, you click Connect to Web 3 inches directly on the Block Explorer. Your wallet will sync. Now you have the power to execute core functions. Navigating the proxy maze. In our previous videos, we discussed the proxy pattern, the method developers use to upgrade their protocols. If you try to interact with a modern DeFi protocol through a Block Explorer, you will inevitably hit this roadblock. You paste the contract address, you go to the Contract tab, but you only see 2 or 3 useless functions like Upgrade to or Implementation. Where are the withdraw or swap functions? You are looking at the proxy contract, which has no financial logic, it just holds the money. Modern Block Explorers have a built-in solution for this. Under the Contract tab, you will see options for Read as Proxy, and write as proxy. When you click this, the Explorer automatically detects the underlying implementation contract, fetches its ABI, and displays the correct financial functions, but executes them using the proxy's address. If you do not know how to read as proxy, you will be completely locked out of interacting with 90% of top-tier DeFi protocols in 2026. The emergency exits practical applications. Why would you actually do this? Let's look at the 3 most common survival scenarios. Scenario 1. The UI is down, and you need to withdraw. You are providing liquidity to a yield farm. The market is crashing, and the farm's website goes offline. You go to the Block Explorer, find the pool's contract, connect your wallet to Write Contract, and find the emergency withdraw or withdraw function. You input your pool ID and the amount, click Write, and sign the transaction in your wallet. Your funds bypass the dead website and return to your wallet. Scenario 2. Revoking a dangerous approval. You realize a decentralized exchange you used yesterday just got hacked. The website is compromised. You need to revoke its access to your USDC. You go to the verified USDC smart contract on the Block Explorer. You go to Write Contract and find the Approve function. You enter the hacked exchange's address as the spender, and you enter the amount as 0. You execute the transaction. You have just mathematically blocked the hacker from touching your money, without needing to rely on third-party revoking tools. Scenario 3. Claiming airdrops. During highly anticipated token airdrops, the project's claim website usually crashes within the first 10 seconds due to millions of users refreshing the page. Smart users don't wait for the website to load. They go straight to the airdrop smart contract on the Block Explorer, execute the claim function directly, and secure their tokens hours before the retail crowd can even get the website to render. Simulation, the golden rule of direct interaction. Interacting directly with a smart contract gives you God mode access to your funds, but it also removes all the safety rails. If you type the wrong parameter into an array, or format a token amount with the wrong number of decimals, your transaction will fail, and you will lose the gas fee. Worse, if you interact with the wrong function, you could permanently lock your assets. In 2026, you never execute a direct contract call without simulating it first. Tools with built-in simulation features of modern wallets allow you to test your exact Block Explorer transaction in a sandbox. Before you hit confirm, the simulator will tell you exactly what will happen. If you call this withdraw function with these parameters, the contract will send you 5,000 USDC. If the simulator shows an error or shows 0 tokens moving, you know you inputted the data incorrectly and you just saved yourself a costly mistake. Conclusion: websites in Web3 are a convenience, not a necessity. True decentralization means that as long as the blockchain is producing blocks, your access to your capital is completely uncensorable. Learning to read an ABI, navigating proxy contracts, and executing raw functions through a Block Explorer transforms you from a dependent user into a sovereign operator. When the front ends fail, and they always do during extreme volatility, this is the skill that separates the professionals from the victims.